Okay, we are starting now. I hope everyone is fine. Let's get start with our session. So yesterday we just touched the introduction, and still it is part of introduction. There we are talking about types of network. These three names, LAN, MAN, WAN, we have heard many times, even from our school colleges. So what is new we can talk about now. So let me start with LAN only, because some of our friends are very new in the domain. So for example, we are the network we have in a building, and that building we have, for example, one of the switch and couple of computers are connected, and now they are close. They can connect with the single Ethernet wire, or maybe there are multiple switches, then further computers are connected. Still we will consider it as a local, because they are locally connected. And sometime multiple buildings are there, and now these buildings are closed. Means we still can install the wire, right? But now these buildings would be little far. Computers were inside the building. Now couple of buildings when we are connecting, that might be in same city, that might be in same campus or university. So there is a limited geographic area, and multiple buildings or multiple networks are connected. We call metropolitan area network. And now when it is beyond our scope of geographic, or the wide area network, which we call, or I can call it internet also, because every one, now one building local area network, which we call, that is for company A, and that is in India. Okay. And or maybe that is in Mumbai. Another building is there, that is in Chennai. Another building is there, that is in Chandigarh. Another building is there, that is in Delhi. And another buildings are there that in UK, US, like anywhere. When they are connected with each other, that we call WAN, wide area network. And WAN or internet is almost similar thing. Multiple local area network and multiple metropolitan area networks are connected with each other, and they are making the internet, and that we call wide area network. So these three simple terms which we have heard many times. Now something new we have when we are stepping inside the network domain. Let's start with WAN. Now what is that? In our home network, in our house, we have router, we have multiple laptop or mobiles connected with the same network. We have Internet of Things like devices connected. Nowadays, refrigerator, washing machine, CCTV camera, a lot more devices are coming, right? All that network devices, or the devices which is connected in my network, is for personal use. Vigesh, you want to say something? Yeah, so personal area network, which we call the devices we have in a personal environment, and that is for personal use also, that we call personal area network. And then we have SAN. Now there are two SAN basically. What is the difference? Let me tell you. Two SAN, but the first SAN which we are talking about, data is very important for everyone, for every company, even individual user. Data is very important. Now, if we are storing this data, and tomorrow in case the hard drive is fail or any storage optical is fail, then we may lose the data. But when we don't want to take a risk, so we are making copies, multiple copies of the data. So in case one is failed, there would be another copy as a backup. So even the whole data center has a replication, but what we are not making it manually, we are just saving it one time and automatically it is replicating to another. That may be one, that may be multiple. Now this replication is using a technology which we call RAID technology. So now this RAID technology, or leave it the RAID one, the copy or the replication of data is comes under storage, because storage has a network, right? So they are sharing the data with each other. Storage has a network and that comes under storage area network. And then another SAN is when we are requesting any data. For example, we are requesting from my web browser, and then multiple, it comes with the DNS server coming in, right? Then web proxy server coming in, proxy server coming in, more servers, many servers are connected with each other and they are helping each other to perform the task. Now these servers are connected with each others, or maybe applications which are again running on the servers are connected with each other to exchange the data. That comes under system area network. That comes under system area network. And then we have another, which is POLAN. POLAN is what? POLAN is passive optical local area network. What is passive optical? That fiber you might have heard. So the connectivity between the fibers, that comes under passive optical. And if you have heard the power over Ethernet, that also comes under passive over local area network. So about PoE and about type of fibers, we will talk a little more in this show. So that connectivity comes under passive over area network. There are, I think, 11 or 12 types. Now these are the main or important to understand, because here we have like a CAN, campus area network, so we can ignore that. Now this types of network, again, one more thing, we call that enterprise private network, right? And VPN, EPN and VPN, also very important. Now VPN you might have heard. EPN is enterprise private internet network. Now on the entire WAN, which we call internet, for example, any company, for example, company Tata, right? Tata's any company which has like worldwide or global offices, and they are connected with each other. They may using the internet, but they are reaching privately to their each other sites. Using what? Using VPN. Right? So enterprise, you can say like the expensive network, they are using almost all the type of network. They using PAN, they're using SAN, they're using another SAN, they're using POLAN, right? They're using LAN, WAN, MAN, everything they're using. So enterprise private network is the expensive or the biggest type, you can say. And here we are coming back to the slides. Local area network, it consists of a computer network at a single site, typically an individual office building, right? Useful for sharing resources such as data, storage, and printer. Then metropolitan, which is used for college campus or a small region. And it is bigger than a LAN. And then internet or the wide area network, which we call entire country or the entire world is connected, rightly? Then we are moving to next one. Network data, endpoint devices, and network devices and network protocols. Okay, so network data. Now one computer, if he's passing something to any server or any other computer, the data which is traveling over a network, that is network data, simple. The information that has to be sent across a network, for example, web browsing. If we are accessing any Google, YouTube, blah, 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 any application or website, that is network data, any data which is traveling over the network. Then endpoints. Endpoints are the devices where user is interacted. For example, I have a switch, I have a PC. Let me draw it on other. So I have a PC and then it is connected with switch, then it is connected with router. So where user is interacted, they here, there, or here. So here it is connected, right? So which we call endpoint. And similarly, we have phone, which we call voice over IP phone, right? VoIP. And we have printer where user is interacted. And we have like tablet, blah, 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 a couple of more devices is connected here. So computer, tablet, phone, printer, where user is interacted, that we call endpoint devices. Now network devices. Network devices are basically which are helping us to build the network, right? The devices which are helping us to build the network. If we have one computer and I have another computer and I want to make them communicate, I have one interface here, one interface here, I can connect the cable, that is fine. But if I have another computer and one interface is here, but another side it is already used, we cannot add third computer. Due to this reason, we are adding what? We are adding a switch. Then everyone using their single interface connected to switch, and how many users or computers we can add, that is depend on the requirement. We can add more switches also, right? So these are the devices which are helping us to build the network. For one network to another network we want to go, again router is coming. So these kind of devices we call what? We call network devices. So these are the equipments that transfer data between endpoints. For example, firewall, switches, router, and also the wireless access points. Then protocols, network protocol. Protocol is what? Simple language is the basically now we are talking, we are exchanging the information, we are exchanging the knowledge. I am speaking English, you are understanding the same. If I would speak something else and you are not understanding, then it means we are not using the same protocol, we are not using the same, we are not understanding the same language basically, right? So if we understand the same language and two devices are communicating with each other, they also should know the same language, that we call protocol. If this guy or this switch or router, any protocol he is using, he must be aware about. Some of the protocols are already or by default enabled, and some of them we are enabling it. But if we are enabling on one device, then make sure we are enabling it on other end also, so that they can talk, they can exchange the information, they can communication between these two devices. Now, from computer, there might be, it goes to switch. So then switch should know the same, computer should know the same. And from switch to router it goes, then router should know the same, switch should know the same, right? And then okay, so then router may be connected with another router, then these two routers also should know the same protocol, right? So wherever we want to make a communication between the devices, they should know, they should understand the same protocols, and then only they will be able to exchange the information, they will be able to communicate. That we call protocol. The protocol has names. There are many protocols. We're gonna talk one by one in the coming slides. Some of the protocol which we are using specially for routers to make them communicate, to pass the traffic, which we call routing protocols, right? And some protocol are used for the devices to find the information, like ARP. Some they are using for transport, we call TCP, UDP. So there are many, don't get confused right now. So just understand the protocol is nothing, just a set of rules, because protocol is made by someone, right? The language which we are speaking, there is a rule, right? So if we are talking, there is a rule, then only you are understanding the same way I'm understanding the same. So same here, the set of rules are to be followed when there is a communication between the endpoints in a network. I would not say only endpoint. I would not say only endpoints. That could be in between network devices also. Now we are talking about routers, where it is used in the network and why it is used and how it is working, right? So where, why, and how. For example, you started from your house, you want to go somewhere and reaching in a roundabout, the circle one, right? And in that roundabout, there are couple of ways, couple of routes, which is dividing from here. And then according to your destination, for example, this one is going to street number 8, this is going to street number 9, this is going to street number 10. According to your destination, you're going to use your brain and you're going to take decision, right? So we are driving our two-wheeler or four-wheeler, then we are taking decision using our brain. And for example, I want to go street number 10, so I will go reach to this circle and will take right. And in case the same scenario is for my packet, but this packet does not have brain. Now if this guy does not have brain, then there should be someone who can help him. He's reaching here, then router is one who is using his brain. This is nothing, just this is a box, right? This is a computing box basically, whose job is what? Receive from one side, exit from other side. That's what his job is, that's all. He's picking from one side and then delivering to other side. Now here the perform what the task it is performing is to select this other side, this side or this side or this side. How he would select? There would be some information he would have, right? Then he having the list of information. What? That 10 where it is connected, 11 where it is connected. So all that information it is keeping here, which we call routing table. So if in case we are going for a far destination somewhere, in the regular language also we are using this word, right? Which route we should choose, via Delhi or via Haryana or something like that, right? So route is what? Route is just a path to reach that network. Now that particular destination might be connected just directly, it might be connected after some routers. So after some routers also, if there is a destination and this router is aware about, he will make the entry here. So let's suppose there is a network which is 112. So he would make the entry to reach 112. I should forward to this way, because he cannot deliver till 112. He would deliver to just his next router, which we call hope. He would deliver to just his next hope. And then he will also do the same job. He will receive, take a look, then forward, receive, take a look, then forward. So then finally your destination will arrive for your traffic. Now, router, when he is receiving, from where he is receiving, there is a interface. Interface, port, or NIC. Usually 3 terms we are using. Don't get confused. This is basically the what do you call that, port only, where we plug in the cable, right? So every interface of the router is connected with a network. And which network is that we are defining here with enabling the IP address on every interface which we are connecting with. So when he is receiving, he's aware about, okay, on which interface he is getting the packet, and then taking a look in the destination, right? So every packet, we already spoke about in the first class also, every packet have a source and destination address. He's taking a look in the destination and then comparing in the table where that destination is connected, either directly or via some other routers. So wherever it goes to other side, then that interface would be the exit point for that particular traffic. And all that he is doing very quickly, right? He's receiving, taking a look, plug. Okay, so router job is like that, right? Then we are coming to our point, basically where we need it. Do we need it in every network? So the one which we spoke about, LAN. Now every PC is connected with each other or nearby. They don't want to go and talk to the internet. We no need router, right? So whose mic is on? Can you please mute it? Thank you. Now, what I was saying, yeah. If we are sitting in single room and we want to talk with each other, then we no need to go out. We are in same room, we can talk with each other. We no need to call anyone over the phone. We are live, we can talk, and we no need to use the gate for go out. We no need to use the gate. Simply here also in my network, if the computers are connected in local area network and they don't want to go out, they can talk with each other. The computer which are member of local area network, they can talk with each other. But when they want to go out in another network, then they have to use the gate. Simply here also, from one room to another room, if we want to go, then we have to use a gate, right? And that gate we call router. And that is why somewhere you have seen the gateway IP, right? So gate is basically used when we want to go out from our network to another network, right? So that is the location or located where router is located in your network. From one network to another network, whenever you want to go, that might be different VLAN, that might be internet, that might be any other company's network. So wherever different network comes in. So if you are understanding what network means, so let me tell you that, for example, an IP is starting with 10. Another IP is starting with 11. So both are different networks, right? And there in 10 also there might be different because of the network bits. So I don't want to make you confused right now. So you can understand easily here. The first octet, every IP is starting with some numbers, right? And that number, if that is number 10, number 12, number 12, number 11, 12, all are different networks. If one computer is in 10, another is also in 10, they can communicate. They no need router. What they need a switch. Rightly? So this is where router is located, basically. Where router is needed, network change or internet. Now, when I say internet, internet is also another network, right? So again, it falls under this one. Network is change. From local area network, if we want to go in the internet, internet is again another network. So we need router. And then how it works, we also spoke. Where it is needed, we also spoke. And then what was the other? Where, how, and why? Yeah, so why is the basically this is the only box which can help us to make a connection between two different networks. And that is why it is needed. From switch, we can just communicate within the network. If we want to go in another, we must have router, and router is only the one box which can help us to make a connection. So inter VLAN, inter network or internet, we need router. Router implement functions of layer, network layer or layer 3. The primary function of a router is forward the packet according to routing table. This line makes sense now. His job is what? His job is forward the packet, receiving from one side, forwarding to other side. What according to routing table. Now, who is making the routing table? If we just plug in the cable, they started making the routing table? No. We have to configure routing protocols, and routing protocols are helping the routers to making routing table. Right? Don't get confused. Routing protocol is basically configuration to make routers understand how to forward the packets. Then according to the routing protocol, they are making the table. Okay, so router also provide multiple broadcast domain, traffic segmentation, and determine the network and network layer address in subnet. So in easy words, router, if he have, for example, 4 interfaces, 4 must be connected in different network, in different broadcast domains. So here might be 10, here cannot be 10 again, right? So here must be different only. So router condition is that every interface should be connected in a different network. And then third line, the network are defined by router adapters or port to which IP address is assigned. And that is the third line, which is every interface on the router must have IP address. If we are not enabling the IP address or we are not configuring the IP address, router not gonna work. Then fourth line is those IP addresses are the default gateways to PC and other networking devices, right? 1 second, I can't. So every PC, if they want to go outside, they must be aware about where is the gate. So whatever the IP we are giving here, we are giving the gateway IP on every PC or every device which wants to communicate other side, right? So gateway IP. So in computer, what we are providing, one is we are providing IP. That is the ID basically for that particular computer. Then we are providing subnet mask. That is describing how many bits are there in the network side. And then we are providing gateway. And that is the one for router IP or how it can go out. Right? Yeah, Kant.
I wanted to understand from you the broadband that we have at our home, right?
Right.
So is that a kind of a router,
Right.
or how do
Yes.
you categorize that thing? Yeah.
Yeah. So that is multifunctional access point. Multifunctional access point. We have three type of access points, which is one is standalone, and another is a controlled one, and another is multifunctional. Now, why multifunctional? Because this single box it working as a access point also, because it is providing us the wireless signals. Then it work as a router also because it has a WAN interface. It work as a switch also because behind that access point there is like two or four, depend on the model, two or four yellow ports, which we call local area network ports or LAN ports. So then modem is also inbuilt. So multiple features it is providing us in the single box. So that's why we call it multifunctional access point. That is how we are categorizing the home one.
So how is it different from the router that you have just described? I mean, in
Right.
terms of functionality and in terms of other things.
Right. So in this one, it has very low capability to handle the routes. All your routes will be with your ISP, where because it is just directing the whole traffic with your ISP. Then ISP has again commercial routers.
Okay.
Yeah. So this is for home use, lightweight. They made the combination of multiple things in single box. But if we are talking about the routers, which we are talking about, or the Cisco ones or the commercial one, here we have more features to add the routing protocol. We can run multiple protocol. We have the option to control that traffic or manipulate the traffic. We have the capability to run the iOS there, which we want to build a network with our more Cisco devices. We can install, we can configure the firewall, we can configure the agent, we can configure the MPLS. There are multiple features which we have on commercial router, but not on the home one.
Okay.
Yeah.
Thank you.
You're welcome. And multifunctional access point is unmanageable. We can, Varun saying multifunctional access point is unmanageable. In one line, we can say like it is manageable, but features are very less if we are talking about the big or enterprise network, right? It is still manageable, but with limited features. Yeah. Coming back to the slides, someone, Kanta, you have another question, or I can lower your hand?
Yes, that's it. Yeah, that
Okay,
was
thank
all.
you.
Yeah.
Yeah, so going to the next one, static and dynamic. Now they are saying like there are two major type of routers, or I would say not routers. Basically, this is a configuration which we do on the router. Now router, which is a box, is same. Who have not seen how it looks like, let me just show you. This is the one. So if you take a look on the switch, it also looks same, but on switch we have multiple or many interfaces like this. On router we have very few, we have less, right? So we have less interfaces on the um, router, and we have more on the switch. That is one difference. And another difference is there is a WAN interface. If let me open it. So on router, there is a WAN interface and not this one. Let me find a perfect one. Yeah. WAN interface on where it is. Let me remove this clear. Yeah. On switch, there would not be WAN. Console would be there. Other L2 ports also would be there, but WAN interface would be available only on router, even if that is layer 3 switch. So there are two type of switches, layer 2 and layer 3. Router is also working on layer 3. If you have remember the OSI model, right? So we are talking about layers, the layer 3, which is a network layer, and router is also working on layer 3. Then we have switch is also working on layer 3. Sometime question is coming, if we have layer 3 switch, do we need router? So the clear answer is yes. Why? Because on layer 3 switch, we do not have WAN interface. And the WAN interface is required for internet connectivity. If we don't want to internet connectivity, then we no need. Whenever we need internet connectivity, we must need this WAN interface, and that is available on routers. Now we are coming back to the point, the static and dynamic. Static and dynamic is just a configuration on the router. Router is same, model might be same, right? So any single router or model we can use for static configuration. For dynamic, static is in short is manual. Then dynamic one is automatic. What we are talking about manual or automatic is I said every router will make a routing table, and then only he can take decisions, right? And this routing table, if we are building manually, we are making line by line, we are adding line by line, that we call manually, or that we call static configuration. And in the dynamic one, we no need line by line to add all the networks. All we need just a directly connected networks. Directly connected networks. Then only it will talk to another router, and then they will talk with each other. They will update each other. How? Let me tell you. For example, another router and another router. And here, for example, we have 10 network, and here we have 20 network. Between the routers, we must have same network, right? And then we have 30 network here, 40 network here, and 50 network here, for example. Now, if we are telling this router that how to go 50, then what we have to tell is, in case you have any packet destination is 50, you send towards 20, or whatever this IP would be here, that we call next hop IP address. Next hop is what next hop is router, right? So next hop IP address, and that is your goal. In case you got destination 50 in any of your packet, forward that way. And then this router also we need to mention manually, again manually, that in case you're receiving, then you forward this way, then this router will forward and your communication will happen. So what we have done is, we made the configuration here, we made the configuration here. Then while returning back also, we need to tell him, because while returning back, destination would not be 50, destination would be 10, right? Then we have to tell him for 10, you forward this way. And again, we have to tell him to forward this way. So more lines are required. In dynamic one, yeah, in dynamic one, we just need to tell you are connected with 10, you are connected with 20. And same we will tell him also, you are connected with 20, you are connected with 30, and you are connected with 40. Okay. The moment when I tell him you are connected with 10 and 20, he will look both the sides and call others. Is there anyone on 20 network? But there would not be anyone, or other side not a protocol configured, so he will not get any reply. The moment we configure here also that you are connected on 20, and he will also take a look, is there anyone on 20? Yes, he would respond immediately, I am here, let's be neighbor. And when they will become neighbor, they will talk. When they will talk, what they will talk? They will talk like who is connected with them, right? And this router will say, hey, I have network 10. If you need to send anything, no, send it to me, I will forward. And he will update his routing table. Okay, if I need to send anything to 10, I'll send my neighbor. And this router will also let him know that, okay, I have 40, I have 30, and I have 50. And he will make the update here also. If I need to send anything to 30, 40, or 50, I will forward to this router 2. That's so we no need to update every router for single network in the dynamic one. They keep talking, they keep exchanging the information. So tomorrow, if there is no 50, there is 60, we change the network, then they still will send update to each other that 50 is no more available, we have 60, add that one. But if you have static, then if you change the network again, you have to change in all the routers manually. And if we changing here, then we just need to change here, that's all. Single router. So the dynamic one is easy to configure, right? And that we call static and dynamic. Static routers require an administrator to set up and configure the routing table manually and define each route. The dynamic one are intended to discover routes automatically. So it requires minimal amount of setting up and configuration, right? Then router communicate with each other to share the information about accessible path and directly connected networks. So when routers are making this table, they are not just mentioning like the information network where is connected. They also mentioning that how far is that, and in case they have two routers, he's saying I can also send you to 15, he can also, I can send you to 15. Then he'll compare, is this the fast one or is this the fast one? How? That we call metric. The metric is nothing, basically calculation between these two routes. They are doing the calculation, they are trying to where is the static router used? Static router or static configuration, do not get confused. First of all, the static router or the static configuration, basically router is just a box and the configuration is static in small network only. In small network where we have 5-6 routers we can use, or point-to-point routers we can use. But when we have more routers in the network, or the network is big, then we are we are preferring the dynamic one, because it is providing the reachability more dynamically. And in case your one link is failed, it will go automatically reroute to another one. And if there would be slow, or we call convergence, slow convergence, or we call congestion. Now one more thing, when you ask the question, it came in my mind. 1 second. So question is, where is static router used? And another question is, will we do the lab for, yeah. So yeah, Dharamveer, there would be lab for configuration. Now we are just going through the introduction, the basically fundamentals, right? The configuration also will come for static, also for dynamic also. Now let me tell you one more difference between static and dynamic. And there is a destination, right? And there is a source. Now from source, router 1, router 2, 3, 5, 4, sorry, 1, 2, 3, 4, 5, 6. Okay, so we are giving a number just to understand. From router 1 to router 6, if we want to go, and upside I have a static 1, and in static I said you should use this way, because in when I do static 1, and when I make in the entry that for network 6 or router 6, network is also 6, for example, right? So for network 6, you should use or forward the traffic via router 2 only. So maybe this route is fast, but he would not use it, because in static, they are not going to use the brain. Whatever admin has decided, they always follow the same route. Another issue with static is, in my this route, there is a lot of traffic going on, and there is a full congested link, and the link is, you can say, like very slow. Still it would not reroute, because we have another route also to reach the 6. We can go via 4 also, but it would not go because manually configured. In the dynamic one, we no need to tell you should go this way or this way. He only will consider the links, how which one is faster, right? And then which one is faster, or the metric that is especially for dynamic one, which I'm talking about, right? And they are coming with two different algorithms. One is link state and one is distance vector. Two different algorithm. Now, for example, we are 11, 12 people here, right? And for example, from Bangalore to Pune, we want to go. And there is a highway, and there is some street or shortcut is going. Here we have less kilometers. Here we have more kilometers. So some of us will say we will go with the highway, because highway we can go in a good speed. So they prefer the highway. And some of us will say we will select the short one, because here we have less kilometer and we can reach fast. Here they are talking about less kilometer and they are preferring the route. Here they are talking about speed and they are preferring the route. So both are right, or both are like both have their own choices, right? So their thoughts, what they're saying, less kilometer can be reached fast, that is also right. High speed or good speed can be reached fast, that is also fine. Now link state and distance vector is also similar thing. Two algorithms or two categories which is basically made by someone. Protocols are made by someone. Some protocols link state like the OSPF, right? The distance vector, we have RIP, we have IGRP, and this is a hybrid one, EIGRP. Then we have ISIS, right? Then mean to say here is when we have two options from router 1 to router 6, when we have two options, and then it comes to the protocol selection, which protocol is that? For example, the protocol we have OSPF, which is a link state. It will compare the whole link from here to there, which is fast, which is taking less time. And then if we have distance vector, then it will compare what? It will compare the distance or the hop counts. If we have, for example, if we have router 1, router 2, or router 3, or we call 3 hops, then this route is much better for him. That might be slow, but he's not comparing the speed here. He's just comparing the hop counts. Wherever he would found the low hop counts, that would be the preferable route for him for distance vector. But for link state protocols, that is comparing the speed. That is not taking care about how many routers are coming on the path. Now here might be less speed in MB, here might be in GB, but we are crossing more routers, but still we can reach fast. So link state is always better. Dynamic is better than uh, static one, right? So what we have now, conclusion one, static versus dynamic. Dynamic is better. In dynamic, link state is better, right? If we have router to router just directly connected, then static is better because they don't have any other option. And static is faster, easy to select. Where if you have two or more uh, protocols configured on single router, yes, we can configure two or more protocols on single router. Then static by default AD value. Now what is AD value? You might get confused. I don't want to make confusing, so forget it now. So static is perfect for directly connected devices or directly connected routers. Then dynamic is better for bigger network. In dynamic, link state is better for easy configuration and easy rerouting your traffic. In dynamic or in the link state, there is one more benefit that I was telling you, that if you have two routers connected, that might be this is GB, this is MB, perfectly fine. But let's suppose this is fully congested, more traffic is going from here. Then dynamic value is also dynamic. It keeps changing according to the load on the link. If this route is busy, then he will select this one. Okay, so dynamic is better and also easy to configure, because here you're just going to configure on single router whatever is directly connected. In the static one, you have to tell every router about every network. So if you have 10 networks and 10 routers, each router will have 10 lines. You have to write 100 lines. But in case of the dynamic one, whatever is directly connected, for example, two networks. So for each router, two, and you have to make like 20 lines. So you can compare, right? The configuration is more for the static one, and configuration is less and easy to configure the dynamic one. And then later on, they automatically talk with each other. They finding the routes and they updating the routing table according to the information, whatever they got. And also in static, whatever the information you mentioned, they're not going to send updates if there is any change in the network. But in dynamic one, they keep talking. They keep talking, the network is alive or not, the network is changed or not. So routing protocols, static or dynamic, are helping to the routers for communicate between the routers, right? So routers communicate with each other to share the information about accessible path and directly connected routes. Then you have layer 2 and layer 3 switches. Layer 2 and layer 3 switches. So first we're gonna talk about just a layer 2 one. Now one PC, if I have any IP is starting with 10 or network 10, then another PC starting with network 10, they can communicate. And if I have changed the IP here, I make it 11, then they would not. Even they are still connected with physically same switch. Even they are connected with the SIM in the local area network, but they would not communicate with each other because network is changed for both of them, right? And then layer 2. Now layer 2, layer 3. Before we talk about that, let me just revise the OSI model. How many of you remember all the layers? Can you put in chat? All the layers start from 7, 6, 5, 4, 3, 2, 1. Okay. So which is the 7th layer? Just speak that on mic. What is the 7th layer? Application, right? And then 6th layer, presentation, right? Then session, right? Then transport, and then network, data link, and then physical. Perfect. Now, behind the OSI model, there is a story which I'm going to share right now that might be somewhere accurate, but with this story, it will be easy to understand that why we are using the OSI model, right? So for example, there was a company, whatever the name was, they was using some manual, they was doing some manual work with the paper or texting or something like that. And then they met with one agent. They said like, hey, whatever you're doing and you are spending time, if you do the same thing on computers, that would be easy to store your documents also, and the work also will be faster. And they was happy. They said, okay, we will try with the first computer, or for now only with first one. And then they started using it and they was happy. When they was happy, they bought another one also. And when they bought another one, they tried to communicate between these two computers. And they said like, if we are creating the files on one computer, that should be open or shared with another one. They made what? They made a network connection. Okay. So they was happy, still happy. So whatever the files they was making on one computer, it was able to open on the other. So there was perfectly communicate between them. But then, for example, this computer was made by IBM. And then after a couple of years, when technology upgrade them, then they came up with another, they met with another agent. They said like, hey, we have the advanced computer, the fast computer, the computer which you are using right now. It has less features. We have more features. So you buy from our, okay. They bought from our, that company may be from Apple. This is just an example, right? So they met with Apple. Okay. Now they started using the same thing. They try to make the communicate, but it was not working well. How it was working between the IBM to IBM, it was not working well with between IBM to Apple. Why? Because they use their own methodology, terminology, and they use their own one. Both are not fully compatible with each other, and that's why they was facing the issue. And the same issue was not with just one company. There was many companies who was facing the same issue. They have to use, if they are using IBM, they have to use all the way IBM. If they are using Apple, they have to use all the way Apple only. But it should not be an issue for long. Then an organization came who making these standards for industry, and they said we are making the rules, and every brand, especially manufacturers, OSI model is specially for manufacturers who are making the NIC, the motherboard or the computing systems. They said you should follow all the layer wise approach. Then only when everyone using the layer wise same approach, then computer to computer they would communicate without any issue. So today we have HP, we have a Lenovo, we have Dell and many more. They are talking with each other without any issue because they are using the same standard. So that's why OSI model came into the picture. And now every layer, whatever they made, what is the job, what is the work for each, that we're going to talk about. So for example, this is from sender one. Usually we are starting from what? We are starting from layer first, right? The layer one. But here sender one, I'm starting from layer 7, because if we want to send something, any email, any file, or anything which we want to do basically on computer, we are using an application. Currently, if I'm trying to draw something, I'm using a whiteboard, Microsoft Whiteboard. Again, this is application. We are uh, connected via this meeting. We are using an application, Zoom application. Then we are using the file to use the slides. We are using an application, PowerPoint, right? So for every work, user is interacted with application where there is a human understanding, right? The data which human can understand, that is possible or it is accessible via application. So for example, using an application, maybe for example, we want to send an application email, we will use a web browser or Outlook to send one. And after application, then this layer will talk to another layer. It will talk to another layer, then presentation layer come into the picture. That layer saying format change or present to other one. Like application is doing what? Application is making the understanding to human. Then presentation layer is changing the format for machine understanding. Right? The same way which we are understanding, machine is not understanding the same way. They are using their own binary. There are other codes or language programs. So presentation layer making that change and then requesting to another layer to open a session, because we want to send something or we want to communicate with another computer. It is sending requesting to the session layer. Session layer is one, like a session layer is nothing, just a open the link, open the line for our connectivity. So if we are making a call, there is a duration, right? For this much seconds or minutes we spoke. So they are opening a line for our connectivity. Once our call is done, then the duration will be ended. If we are making another call, then another session will be started, right? So this is session which is opening a link between the computers or trying to open a link for particular delivery. Then it goes to transport layer. Now when it goes to transport layer, and transport name itself saying like we want to deliver from one side to another side. So here also we are talking about like from one computer to another computer. And if we go to any transport company or any courier company, they're saying we have two type of services. by road or by air, which you like to use, right? Then by air would be faster, or by road it would be slow, or there might be chances to break down the stuff if we have something like glass or broker one, or basically difference they are describing. What is the difference? Then according to our choice, we are selecting one. So transport layer is also providing you two options. Which one would you like to use? UDP or TCP? So UDP, which we call user datagram protocol, TCP transport maybe, or transfer control protocol, transport control protocol, or maybe transfer, something like that. So which one would you like to use? Then definitely we would like to know the difference. Okay, so UDP is fast and it is slow. When I say slow, it is slower than UDP, but slow is not like it will take one day, right? So it is slower than UDP. Now UDP is fast, but there is no acknowledgement. That is the big difference. That's all. The UDP, basically it will throw from one PC to another PC. That side it is receive or not, he don't care. And also he will not providing you any authentication or acknowledgement that your data has been delivered or not. So when basically any courier company is sending, then we want to see also who was the receiver, right? And in case the courier is not delivered, then what was the reason? So same way, if we don't want the acknowledgement, or we don't want that data was delivered or not, if that was not delivered, then what was the reason? If we don't want the data is not very important, then we can use UDP because it is providing you fast. Where we need the fast convergence, or where we need the fast speed, the for example, the one which we are using right now, audio call or video call or live streaming. If I am speaking and there is a connection loss from my side or from your side, then whatever I am speaking, it would not be delivered and it would not be recoverable also. And there would not be any information that where it was lost, till where you heard, when it was lost. There would not be any information like that. But when we are using the TCP one, we are sending, for example, email, which we are making sense like it is important. And if that is delivered or if that is not delivered, then it can be trackable with the protocol of TCP. But in UDP, there is not any acknowledgement that was delivered or not. Now, when we know the difference, and it is providing you acknowledgement, when it is delivered also, when it is not delivered also. When it is not delivered also, it will tell you the reason why it is not delivered. So when we know the difference, we want to select one for my data delivery. Then I need to select one. I need to choose one. Then who is the one will decide it? That will be decided by application. Just clearing it. That will be decided by, again, the application. Every application or the software, whenever they are making, they are describing it in the program, in the code of the application, which protocol it needs to use. Rightly. And then it goes to, now when they want to send something, there is a address, right? There is a network address, which we call IP address. They need his help. Hey, network layer, I want to send my traffic or my data to particular IP address or particular network. Then can you please help us? Then routers. Sorry. Routers are coming into the picture, and IP address is coming into the picture. That is helping them to find the route how you can reach the particular network, right? Then transport can deliver, but from where it can go, that network layer is helping them. And once they are reaching to their gateway, and then in that particular network, they need to find the right computer, because in that network there might be multiple, but who is the right one? The data link is helping them. The switch, you can call, is helping them. Then via physical interfaces or the cables, they are actually traveling and reaching to the destination. Right now, from sender to receiver, one more thing about OSI, and this is sender 1, layer 7, 6, all the way to 1, and here it is receiver 1 from layer 7 all the way to 1. From sender, when it is going like layer wise approach, from layer 7 to next to next to next, we call that process, there is a, like this process, we have a specific name which we call encapsulation. And then when it is reverse, because when it is on the receiver side, if it will be received by physical, then further data link network, blah blah blah, and finally receiver will open that data on an application which is layer 7, and that process we call decapsulation. Right, so encapsulation and decapsulation is the process. Basically, from sender side we call encapsulation, from receiver side it is decapsulation. Make sense? OSI model.
Harshdeep, I want to understand the UDP and the TCP. Was it
UDP,
UDP? This one and the other one was TCP, right?
TCP.
Yeah. So I wanted to understand the scenarios where the UDP is more useful than TCP. I
Right.
mean,
So
live example, if you have some.
yeah, the Zoom meeting which we are using right now, the audio which I am using, and it is more real time, it is fast. If I will make it TCP, right, then it will be delay. And
Okay.
live, the WhatsApp call, we do WhatsApp call, right, over the internet, and that is also using UDP. So wherever we need speed, we are using UDP.
Okay. And there was another thing that I wanted to ask from the previous slide that you shared. So when we were talking about static and dynamic routing,
Mhm.
so what if the dynamic routing is fast based upon the the algorithm that it has?
It's not about fast, it is easy to track the routes.
Okay. So why is it that we are still using the static routing instead of the dynamic? If the
Yeah,
dynamic
that is what
works
I'm
very
saying.
well.
It's not about fast, but it is easy to finding the route when you have multiple options. But when you have single option, then static is more effective.
Can you give some live example for that as well?
So live example, for example, if you have two routers, right? So
Okay.
one router from your network to another network, or like for here example, you have 10, you have 12. You want to communicate between just these two computers, then no dynamic is required. Static is more than enough, and it would be fast also, because there is no other link.
So basically, if there are no hops, I mean, between the
There,
two networks.
yeah, up to like depend on the network to network. Basically, if the network is small, right, they have like 5 7 routers, then they can use static one. But if they have 50 or 70 routers in the network or the enterprise we are talking about, then we prefer dynamic one, because every day we cannot go to every single router for making the line changes. For 2-3 routers we can make.
Okay. Okay.
Yeah.
Got it.
And if we don't have more networks connected, then definitely there is no requirement for changing the routes for coming years or eras.
Okay. Got it.
Yeah. Yes, Vita, what is your question?
Good evening, sir. Am I audible to you?
Yeah, Smith, I can hear you.
Sir, I wanted to ask about the sir, use of WAN interface on the router, and if it is not available on the layer 3 switch, then how can we say a switch is working on layer 3 if we are not connected to internet?
Very
As
good question. Very good question. Let me answer this one. So layer 2 switch, it is working only on single network, which I said. If I have any different network, I have 11 and I have 10 here, then I need what? I need a router, right? So let me, in easy words, let me tell you that if I want to make them communicate, either I have to make as a 10, or if I still want to make it 11, keep it 11, and still I want to communicate, then I am adding, for example, router. When I'm adding router, or which we call VLAN, right? So VLAN concept will come into the picture in the coming slides. If I want to make them communicate, I need a router. Now, if router is coming, then first my packet will process here, then it will process here, then it will process here. So 3 times it is processing, which is time consuming process. And then they came up with layer 3 switch. Router is inbuilt now. I would not say entire router, but only few features, because router we was going through because of understanding of the IP address. Switch was not able to do that, right? And then we added that feature into the switch, and they are working to understand the IP address, and we started saying this is my layer 3 switch. It does not mean it is a router. It has small features only on the IP understanding, so that for my inter VLAN routing, layer 3 switch is made for inter VLAN routing, not for internet connectivity. Did I
that
answer your
means
question?
it is connecting to LANs, not
Not to WAN, not to internet. Layer 3 switch is not for internet. Layer 3 switch is for multiple networks.
LAN networks.
Multiple VLANs basically. Yeah, multiple VLANs in the local area network.
Sir, then it is not reading the IP address. Basically, different
Layer 2 switch. Layer 2 switch cannot understand or take decision on behalf of IP address. It has to get help from layer 3 device, which is router, and then which was taking like more time for processing, and they made one box with more. Let me make it easy. For example, long time back, we used to buy torch separately. We used to buy calculator separately. We used to buy Walkman for music separately. We used to buy camera separately. This would be easy, or a smartphone is easy, where we have all the features, right? So what they did is, router was a separate, switch was a separate, they combined it, which we call layer 3 switch. Now in smartphone we have camera, but it is not completely DSLR. There is some limitation, right? So similarly here, they added router in the layer 3, but not the entire router, only the required one.
to connect different networks, basically.
Connecting the different networks, basically. Yeah.
Sir, then if on router interfaces we configure different network on different interface, what is the use of WAN interface? Actually, I'm not getting that WAN use of
Okay.
the WAN interface. When we
Okay,
are
let me
connecting
tell you
between
that.
network, we can connect to internet via any of the interface of router.
Okay, let me tell you that ISP, the internet service provider, when it is delivering the, it is giving the cable at your equipment, that you have to enter or plug in the WAN interface. Then only you will be able to communicate with the ISP, because they have more devices like MUX. They have OEC card, something devices are there, which is passing the signal to your WAN interface, which can enable the internet connectivity. And that WAN interface is required for internet connectivity, right? And on the layer 3 switch, today there is no WAN interface. So multiple network router also can connect, layer 3 switch also can connect, but internet connectivity can be provided by only WAN interface that is not available on layer 3 switch. You got my point?
So at what level the WAN interface is present then? Is it something outside of the 7 layers? I mean, some kind of physical equipment that we have to plug in, or how does that work?
I did not get your question. Like,
I'm
it is
saying,
part of.
yeah. So the WAN, I'm asking that at layer 3, you're telling us that there's no WAN, right?
Layer 3 is not WAN. No. So WAN interface, when I'm talking about, that interface is physical one, right? Where we plug in the cable. Interface is a physical one. So it will come under layer 2. When I say NIC, network interface card will come under layer 2.
Right.
But it is providing you IP connectivity for internet, which can make a connection with your ISP service provider.
Right.
Sir, if we connect, if we configure IP of in the domain of same as the network of ISP interface on any other interface of router, that you mean it won't work?
No, it would work only for WAN interface, not on any other. And that is what I'm saying. The commercial router, it has all the interface work as a WAN. It can work as a WAN, like any interface IP you can provide. But on the home router, we have just single. So it is making just a connection between your internet service provider. But here you can get more also, more networks also. So
Okay, you mean
don't get
home to
confused.
home, for home connectivity we need WAN interface, and for enterprise or any other like
For home also we need WAN.
WAN.
In short, now if you have router nearby in your house, you take a look on the backside. There must be a WAN interface where the cable is connected, which is coming from your internet service provider. So
So
in
the
short,
other routers which are like good routers used by ISP, by company, by enterprise like Airtel, Vodafone. So sir, the routers used by them need not to have a WAN interface. They can use other interfaces as well.
for net, see, two different things are there. When I say internet, right? Earlier only I said WAN is equal to internet. Then another thing is network to network connectivity. So when we want network to network connectivity, then layer 3 switch can be used, router can be used. To have, you have two options. But when you are connecting to internet, then WAN is only the interface which can provide you the connectivity. Now this is something between your networks only, 2 or 3 networks. Here we are talking about the entire world.
So at
And
layer
that
2, yeah, sorry to interrupt. So you're saying at layer 2, when we have, we can connect through WAN. At layer 3, we have the option of connecting between the different networks, which is the router plus switch that you just told, right?
layer 3 switch, right?
Okay.
Varun saying seems in fiber to home WAN is not used. See, fiber is another option which is connected the WAN only. So WAN always would be there whenever we are connecting to internet. Just remember this single line. WAN connectivity is required whenever we are connecting to internet.
Yes, Harsh, I totally agree with you that WAN connectivity is required. But I think it's just an observation that if you are having a direct fiber into your home and the router you could see, so it would be having just a yellow color cable inserted into the router, not onto the WAN port particularly. So
But
the WAN port and LAN ports are all vacant. Correct.
right. So you are right, Varun, but let me tell you that WAN interface, if you take a look on the WAN interface, right, and that is RJ45, right?
Yeah.
Fiber is
Exactly.
another interface, which is we call SFP we are using in that, like
Yeah.
another format. Like we say USB 2, USB 3, but both are USB, right?
Correct.
Right. So just the interface shape is changed. For fiber, we need more fast connectivity. So we are using another shape of interface, but still we are calling it WAN.
Correct.
Just like, yeah, the phone one, if we say USB 2, USB 3, both are providing you charging, but USB-C is faster and the shape is changed. Still we call it USB, or still we call it charging point.
Exactly.
Right? Okay. Anyone else have question on the same? If no, then you can drop the meeting. We
Sir,
are about to end. Yes. Please tell me.
sir, just like last point, if I am managing the LAN of a university, let's say, and if I want to connect to the internet, then the router connecting me and the LAN and ISP would be via the LAN interface of the router
So
of
you're saying if
not
you have a LAN connection somewhere in university and you want a internet connection, right?
yes, sir.
And
The
then
router would be used at the LAN and also
yeah, so router would have two arms. One would be connected with the ISP, one
ISP
would be
and
connected with your LAN.
yes, sir. So, sir, LAN would be at the end of router would be at the end of LAN also.
So router has multiple interfaces, as I said, right? One, two, or multiple. So one would be connected in another network, which is coming from your ISP. Another is connected with your inside network. So here we would have some local IP. Here we would have some public IP. Then only it
The
will provide you the connectivity with internet.
the where you have configured the 10 network, that would be WAN interface. You want
No, that would be LAN interface. Here we are mentioning, right? That would be WAN interface. Sorry, LAN interface.
20 would be WAN interface.
Right. 202 or 20, any network you can understand. Yeah. So that would be WAN interface.
Okay. I thank you, sir. Now my doubt is clear.
Okay, you're welcome.
Thank
All right, Lee. Everyone, we are good for the day. You can drop the meeting and just see you tomorrow by same time. Right?
Yes.
Okay.
Thank you, sir.
Bye
Okay,
bye.
Harsh, thank you.
Thank you,
so
sir.
much.
Good night.
Bye bye. Good night.